Hey everyone, I'm Mike Cook. I work at the University of Falmouth, part of the Metamakers Institute, who is putting on the ASYNC conference that this talk has been recorded for. And today I want to talk to you, ironically, about why I don't use machine learning, but hopefully I'll use it as a conversation for kind of some of the things I wish machine learning could do, maybe. I'm just going to start giving you some background on me and talk about my field, which is computational creativity, and talk about what the needs of that field are, or kind of my specific corner of it. To give you some background on kind of where I started and what I've been doing or what I get up to, a lot of it involves surfacing stuff to people in a more accessible way, funnily enough, which will become relevant later. So I've been working on a tool called Danesh, which was a toolkit for helping people engage with procedural generators in a different way, kind of putting more information out there so that they can see it and get a better understanding of it without writing code, maybe. I also have made some games like Tombs of Temeria and Clay, and they use procedural generation as a game mechanic, and visualization is a really big part of that. So you have this system that can generate things like levels in games, and you give players control over it, and the biggest factor there is whether they understand what they're doing, whether they can see what the generator is going to do so that they can plan around it and use it. Probably the focus of my research is a piece of software called Angelina. Angelina is an automated game designer, meaning that it produces video games as much on its own as possible. So the trajectory for the project has been finding ways to make the system more independent. And because I work in this field called computational creativity, a lot of it's also been about understanding why people do or don't feel that Angelina is a designer, that Angelina is independent, or that Angelina is creative. And that's kind of what I want to talk to you about today, is where that comes from. So the way Angelina works, it's not actually important to know how Angelina works today. Ironically, I'd like you to treat it as a black box for today, which is not how we would normally do it. But the idea is that there's a bunch of science in a box, and you press the button, and at some point, a video game pops out. And this video game is beautiful and moving and revolutionary, and kind of each one sort of changes the games industry in a different way, I would say. That's the main theme of the project. Like, they've all kind of produced revolutions and inspired a generation of game designers, that kind of thing. I'm obviously joking, they're awful. But if you were doing, like, for a lot of game generation projects, you might just stop here. You might just say that this system produces games, and that's fine, and that's what it does. And if you were building this for, say, the games industry, if you were writing a grant and trying to explain the system, that would be enough. You build a system and it makes games, and those games are either good or bad. And the proof is sort of whether they're good or not. Like, that's your evaluation for the paper, maybe. But Angelina has another half to it, and that half is talking about Angelina itself, how it makes the games, why it makes the games, and this forms a kind of backstory for the system and for the things that it makes, and that is what is kind of the legacy of this system and why it's important, I would say. And just to talk a little bit more in depth about what I mean by that, some of the things that Angelina does is talk about what it did and why, and we call that framing in computational creativity. So, for instance, if it uses a picture of Barack Obama in a game that it makes about a newspaper article, it might say, I chose pictures of President Barack Obama because he was mentioned in the news article I read, and I chose pictures of him smiling because I think that people like him. I think that people think that he's a good person. And that's a way of telling you that the system knew what it was doing when it used that photograph, so that you don't think that maybe it was just randomly guessing or this was a coincidence. So it's really important. And it's important not because it affects the game. The game is still the same game. It doesn't matter. Like, the text that we put with these games, we put them next to it. It's kind of like the text on a wall in a gallery. The text doesn't change the game in any way, but it changes you. And if you read the text before you play the game, then it will color your perception of the game as you play it. And if you read the text after you play the game, it might change how you remember the game, or how you think about it, or how you tell other people about it. And that's because a lot of what computational creativity is about is not necessarily the software itself, but how people perceive that software, what they believe about it, and what they think about it, how they mentally model it in their head. And there are a lot of other factors in play, but the system being able to talk about what it does is important. And so really making good games has become less the focus of the project over time, even though it's obviously still would be nice, and I do want it to happen. But really it's about what people do when faced with this project. How do they feel about it? So what do people like about Angelina? What have they told me that they liked in the past, or what have I seen them like? They like seeing justifications for decisions. They like reading Angelina's framing information. On the whole, that system really works. That's why we do it. That's why we research around it, because people like to know why a system did something. They also, I think, like seeing commitment to doing a creative thing. So earlier I mentioned that if you were making a game generator, you might just stop when it outputs a game. And actually, there's kind of a more extreme version of that philosophy in certain parts of games research, I think, where, for instance, I think there are people who would believe, at least in terms of game generation, that Space Invaders is objectively a good game, and it's the same game whether you have it called Space Invaders or have it called something else, and whether the characters are aliens and rocket ships or whether they're just boxes. And there's like one argument where you can understand why they would think that. And there's another argument where actually having the system fill in all of these details that may not seem important actually shows a commitment to being creative. And like I said, if you were making this project for like a game developer, you might just say, look, the system doesn't need to name these games. It doesn't need to decorate them. It doesn't need to choose art assets for them, because a human will come and do that. But in computational creativity, doing those things is just as important as coming up with a unique rule set or testing to see if the game is balanced. Those things are important because they show that this system is being creative. It's doing game design. It's doing game development. The other thing that people like is the kind of emergent mythology around the system. And by that, what I mean is, no matter how much you try and describe the system accurately and openly, people will read into systems like this, particularly systems that are designed to be independently creative. So when Angelina started researching into how people felt about celebrities, people read into that. They made jokes about how Angelina felt about politicians or people who were in films. And I try and mitigate that as much as I can. Like, I try and talk about Angelina in a fairly neutral way, but you still make jokes occasionally, and people want to make jokes. That's part of their engagement with it, and it shouldn't be discouraged necessarily. But occasionally that myth kind of gets away from itself, and people start believing things about Angelina that aren't really true, I guess. And that's something that you need to be aware of. Things that people didn't like about Angelina was knowing that a human being programmed it. People definitely did not like that. And for some people, that is just that is a unavoidable problem. They will never accept Angelina as creative if they know that someone programmed it. They've told me that, like verbatim, basically. Not everyone, just some people. Other people didn't like the fact that it was deterministic. And by deterministic, I don't necessarily mean that there's no quantum process going on here, but just the fact that there's a paper trail of reasoning that someone can trace back and find out ultimately that the reason Angelina did this thing was because there is a piece of data somewhere in a website or a database that affected it enough to do this thing. Like, people don't like that feeling. And sometimes the thing that people didn't like is literally anything, because it's the internet, and even if I explain to them that Angelina does X, they will ignore that, interpret that Angelina does Y, and then tell me why they hate the fact that Angelina does Y. And you can't help that, really, because it's the internet, but people will find something to not like, basically. So I've tried to break these down into two quite clear categories, because I'm going to make a statement now with this next slide and then talk about it for a bit. And it's, I guess, maybe a fairly strong statement, or maybe it's not. Maybe you totally agree with me. But basically, thinking about Angelina as a cultural artifact, something that exists that society has responded to, I want to talk about machine learning for a bit. And machine learning is effectively a shell game for intelligence. And I want to be clear here that I'm not saying it is intentionally used in a hostile way as a shell game, but I am saying that accidentally, one of the reasons why machine learning has ended up where it is because it has this property. Let me explain what I mean by this. People actually have a pretty good understanding of what code is. We talk a lot about code education in schools, but if you go back to the 1980s or 1970s, you'll find like books in children's libraries or magazines on shelves that just talk about code very casually, like books aimed at 8-year-olds that explain what a register is, that kind of thing. And even today, people understand that someone sits at a desk and they write words into a machine, and that machine can then execute those as instructions, and that's how a program works. And effectively, they understand that there's this supply chain that starts with a human programmer and ends with a program being executed and having these actions done. And this understanding is crucial. It's core to some of the things that people don't like about Angelina, like the fact that there is a human in that chain. And it's also crucial because there is a way to talk about anything that Angelina does. That thing that people don't like, the fact that there's a paper trail, is also fundamental in allowing Angelina to explain what it does. It's really, really important and crucial. By contrast, machine learning is effectively wizard magic from space. Pretty much, like, for a lot of people, it might have been that like a wizard descended from Mars 3 years ago and just imbued technology with this magical power that it can now just do certain skills. The public in general do not have a very good mental model for what machine learning is. Journalists often don't have a good model for it. And the metaphors that we do use, even words like learning or neural network, are pretty misleading and lead people to extrapolate and exaggerate certain qualities and kind of run away with things. And I'm not saying that the public are stupid or anything. I'm saying this is actually very natural, and people do it everywhere, including within computer science, even people who work with these systems sometimes. And this is a problem. And so we've gone from people like understanding that there's a link between someone making a program to now having like who creates a machine learning system. It's unclear. Some people will know that there's data involved, but that data came from thousands of people. So none of those people were individually responsible. None of them are programmers either. And so no one's really sure where a machine learning system comes from or whose responsibility it is. And this paper trail of explaining why something happened or why an output was chosen has now gone. We don't know why things were caused by, what things were caused by. Like, we don't know why a system has decided to act in a certain way. And this, I'm obviously presenting these as a negative, but actually it can be extremely powerful, and it has been powerful. And it is tempting to exploit this, and it is very exploitable. And that's why today a huge amount of modern AI, I would say, is primarily marketing exercises. And I don't mean like people trying to further the efficiency of GANs or whatever, but I mean out there in the real world, like ING, banks, tech universities, like doing things like feeding Rembrandt into a machine and making, quote, a new Rembrandt. These are highly misleading marketing stunts that are designed to capitalize on the fact that people will read into a system and exaggerate what might be going on inside it. And if all you need is like a shot in the arm for PR, this is actually really good. Like ING benefited massively from their Rembrandt project. But long term, they couldn't create more Rembrandts because people would start to catch on to what was going on. And it's kind of dangerous, and it harms the reputation of systems like Angelina if we do this too much. And so I kind of have this wish list of things that I'd like to be able to do with machine learning systems. And maybe I can. Maybe you'll tell me that actually I'm wrong. But I think many of them can't be done yet. So for instance, I'd really love to be able to frame decisions. So if Angelina looks at a bunch of games and learns which games are maybe interesting or which games are hard, which games are easy maybe, and then I give it another game and I say, is this game hard or easy? I need to know features of this game. I need to know why it has chosen that this game is a 3 out of 10 on the difficulty scale. I need to know what that means. I need to be able to anticipate edge cases. I've seen machine learning systems just go haywire on particular inputs, not necessarily adversarial ones, just things that break our expectation of what we thought it had learned. And obviously any system can make mistakes. Angelina already makes mistakes, but right now it's easier to explain those mistakes. It's easier to hunt them down and debug them. And that's really hard with machine learning systems, as far as I can tell. With some machine learning systems, I should stress, some techniques. A lot of the techniques which are fashionable now. And also, one thing I'd really love to be able to do if I was going to use this kind of a system is to identify which data is providing the most contribution to a particular outcome, or which one is producing the most surprise or causing the most disruption. I think that would be really interesting, and that feels like something that might be doable, and I'd be really interested to hear about that kind of thing. But my overall thing that I wanted to get across in this talk is that I feel like the Chinese room gets misinterpreted a lot, and I feel like even the original proposal by Searle is like misses the point of his own example, which I guess is kind of an arrogant thing to say, but I don't really mean that he misses the point, but just that when I hear this story, I interpret it in a different way. The Chinese room isn't actually, like, the person inside the room or whatever is going on inside the room is completely irrelevant. The Chinese room is about the walls that have been put up around it. Because if you took down the walls and you showed people this book that this guy has, this magic book that has every single possible phrase in Chinese and a response to it, people would be amazed. That book would be so incredible, it would go down in history as one of the greatest things we've ever created. And instead, we've put walls up around it so they can't appreciate this cool thing that is inside it. And instead, they're being encouraged to guess about what might be happening. And ultimately, the only thing that can happen is that they can be disappointed. We can't meet those expectations. We can only ever fail to meet them. And for me with Angelina, I want to, have a little viewing window that people can peer into the Chinese room and take photos of what's going on and marvel at it. Because even though it's not as good as the myth of this machine that understands Chinese, it's still really cool. And it's more important that people appreciate what the system is doing than be duped into believing what it might be doing. Thanks for bearing with me. I'm obviously not an expert on machine learning at all, and I hope that wasn't too uneducated. I'd really love to hear anything. If you want to talk to me, my office is in Twitter. That's where I live. I'm @MTRC. If I'm not in my office for any reason, you can always email me, mike@gamesbyangelina.org. And if you want to hear more about Angelina or play its games, you can go onto the website of the same name. Thanks very much for listening. Cheers.